So we're dealing with these centroids. Table 2 on the front cover of your book. This gives you where the centroids are for each individual shape. Now we're going to have complex shapes eventually like this, where we have 2 centroids and we got to find the center of the entire shape. But for now, we just have a simple shape. And if you look on table 2 on the front inside cover of your book, now if you have one of those illegal international editions, you may have to search for these tables or use the handouts. I don't know if they're included. So that's what we're doing here. And you'll get the gist after a couple problems. It's pretty self-explanatory. And it's kind of fun, actually. More fun than forces. Well, for the layman, you guys now are force experts. So you're like, man, give me some more of those things. So let us begin on, we'll just start with a regular old Joe problem here. We'll start with something simple if I can find something simple. We'll just start on page 152. And I think I have most of these for homework, but 7, 8, 10, 11. We'll just do 7 together. And it's just a basic shape like this. So I'll change the numbers, actually. I'm not going to do number 7. I'm going to do one like number 7. I'm just going to change it up a little bit. I'm deleting this, sorry. I don't want to do your homework problems because there's so few of them. I want you to use those for practice. So let's just switch it around and do it upside down. How's that? And those are supposed to be straight lines, but they're not. And let's give some distances here. So we'll say that this is 6 inches. This is 3 foot. This is, what's that look like? 1.5 feet? 1 foot, 6 inches. And this here looks about like 1 foot. And our goal is to find the center of this shape, right? So we want to find where it would rotate, or what we call the centroid. Now, you can see that this shape is symmetrical right here, right? So for all of these, we want to pretend that there's a Cartesian coordinate axis right here that it lies on. And this just makes me want to get rid of this line, so it makes it a little neater. So when you look at this, if I were to find X bar is the center of the shape. You can see from our drawing that X bar, which would be this distance right here, from the vertical axis to the center of the shape, that's X bar, that is going to be 1.5 foot, or 1 foot 6 inches, however you want to write it. Or we could say, what, 18 inches? So that's X bar. Do you see how I got that? Anybody have any questions on how I got that? Now, in the Y direction, we have 2 separate shapes. We have shape 1 on the top, or let's call shape 1 on the bottom, and shape 2 on the top. Now, each of these shapes has its own centroidal axis, or center. And since they're rectangles, it's going to be directly in the middle. Oops, below, sorry. Now they both fall on that symmetrical axis. This is what we call Y1, that distance there. This distance we call Y2. Now if you look on the cover of your book, you can see that for a rectangular shape, the center is in the middle of the vertical and the horizontal. So y1 equals how many inches? 3 inches. So we know that 1 foot 6 inch, that's 18 inches. Y2 is from here to here, which is how far? 9 inches, plus from here to here, 6 inches. So Y2 is 15 inches. Y2 is a measurement of the center of the shape to the vertical axis or the horizontal axis. So that distance here is that plus that. Now we have to find the area of each shape. Area 1 is 3 foot, which is actually 36 inches. We want to put everything in inches. 36 times 6. We can write that out or leave it as 36 times 6. It doesn't matter. 216 inches squared. And area 2 is 18 inches. 1 foot is 12 inches. So 18 times 12. 206. Is that the same? Did I have, are this exactly the same? How did I manage that? Huh, how about that? Luck of the draw, right? Does everybody know where I got those numbers from? Now to find my centroidal axis on the y, y bar equals the sum of the a's times y over the sum of the a's. So y bar equals a1 y1 plus a2 y2 over a1 plus a2. So y bar equals 216 times 3 plus 216 times 15 over 216 plus 216. .31 inches. Now that point is right here. That is y bar. Y bar. You can see it's the long shape on the bottom pulls it down, and it's between the two centers. And that's how you do these problems. You find the center of the shape, and all you do then is find where the center of each individual shape and the center of the overall shape. And this one was easy because it was symmetrical about one axis. Anybody have anything they need clarified there? All right, let's try another one. I'm just going to make them up, although it's not the best, but oops, sorry. Let's do a square with a circle and a square, or a rectangle inside of it. I don't really like that rectangle. Now these are cutouts. Doesn't look symmetrical enough. All right, so we have a square. Let's make it, I don't know, 2 meters by 2 meters. Then we have a radius. I'll make it, I don't know, what does it look like? 0.2 meters. And then our cutout is 0.5 meters by 1.5 meters. I'll give you a minute to draw that. All right, so now this object is symmetrical, and we want to create our axes here so we can see where we're getting our measurements from. X bar is easy, 1 meter. Oops. X bar is 1 meter. Right, from here to here, 1 meter. Now let's start putting our individual distances in. First distance, we got 3 shapes here. We got the shape of the big box, which is right in the middle. From here to here, we're going to call that shape 1, Y1. Y1 equals 1 meter. Then shape 2 is this cutout. So Y2 goes from here to here, which I didn't give you enough information for. Sorry, that's what happens when you make them up off the top of your head. Let's call this a 1/2 meter. Oh no, that was the eraser. Let's call this a 1/2 meter. Oh, I can't. We'll call this 0.4 meters. And this distance here will be to the bottom of it. So to the bottom of that circle is, I don't know, what's that look like? 0.7 meters. So we'll look at that. There's our picture. That'll work. So Y1 is to there. Y2 is from here to here. So it's 0.25 to the middle of the box, right? So 0.65 is that distance. And then Y3 goes from here to the center of this shape, which is, you add them all up, 1.6, 0.4 plus 0.5 plus 0.7 plus 0.2, because that's the radius. And this distance here then would be 0.2. So 1.9, 1.8 meters, which is impossible based on our picture. Oh, Mr. Manning, poor Mr. Manning with these crazy made up problems. We're going to have to call this 0.5 too. So 1.6 meters. So if we call this shape 3, that's 1.6 meters to the center of that shape. Sorry, do you follow me? Anybody have any questions there? You've got to go from the axis to the center of the shape. Now we're going to find all of our areas. A1 is 2 times 2. 4 meters squared. A2, another rectangle. So that's going to be 1.5 times 0.5. 0.75 meters squared. And A3 is a circle, so that's pi r squared. So that is 0.13 meters squared. Anybody need anything clarified there? Anybody? All right, let's do the math then. So y bar equals A1 Y1 plus A2 Y2 plus A3 Y3. Is that right?
Yeah, and then you put it over A1 plus A2 plus A3.
Oh, it's a trick question. It's not right. Why isn't it right?
You put it over A1 plus A2 plus A3.
Because
No,
they're
it's
cutouts.
subtraction. Those are cutouts.
Oh.
So you put over A1 minus A2 minus A3.
Mm.
When it's a cutout, you got to make sure that you're subtracting because it's
Well,
making it smaller.
maybe the cutouts make it heavier. Maybe it's some sort of a
You have to
anomaly.
fill it. You have to fill it with concrete or something. Who knows? All right, so now let's try it. Y bar equals 4 times 1 minus 0.75 times 0.65 minus 0.13 times 1.6 over 4 minus 0.75 minus 0.13. Let's see what we got. .06 meters. So it's pretty much right here. The giant cutout on the bottom shifts it up a little. Questions? All right. Ready to try another one? Oh, I know you are.